Lesson 2 is all focused on writing equations of tangent lines, lines tangent to some curves. So anytime you see a question saying write the equation of a line tangent to a curve, you're going to write down this point slope form of a straight line. And what we need to do is fill in the y1, the x1, and the m. And that's what today is all about. So you should write down point slope form y minus y1 equals m times x minus x1. Okay, so example 1, we're going to write an equation of a line tangent to y equals x squared at x equals 3, and immediately I'm going to write y minus y1 equals m times x minus x1. All right, so first thing I should do is fill in any information that I already have, and one information I have, a piece of information I have is that x equals 3, okay? So I should go back here and specify, this is the equation of a line tangent to a curve at the point x1 comma y1. All right, x1 comma y1. So oftentimes you're given the x1. You're given the x value. x1 equals 3. Okay, and then how do I determine my y if I know my x? Well, I have a nice function here, right? It's y equals x squared. So I know that my y is just going to be equal to x squared, which is 9. So now I know that y1 equals 9. And I can go ahead and let's rewrite this. Y minus 9 equals m times x minus 3. So the last thing I need to determine, the last piece of information I need is, what is m? Well, m, as you know, is the slope of the line, right? That's why this is called point slope form, because you can write it just knowing the point and the slope. The point is x1, oh my gosh, the point is x1, y1. The slope is your m value, right? So how do I determine the slope of this function at x equals 3? Well, I need to know the derivative. I need to know y prime, right? Because y prime will tell me the slope of x squared. Y prime is equal to 2x. So if I know that x is 3, then that's going to tell me that my slope at this point is going to be 6. So then my full equation then is just going to be y minus 9 equals 6 times x minus 3. And that is the equation of the line tangent to the curve x squared at x equals 3. Okay. So let's do another one. Let's do x cubed at x equals negative 1. So again, we're going to write y minus y1 equals m times x minus x1. All right, what is x1? x1 is equal to negative 1. Okay, y1 is going to be equal to negative 1 cubed, which is also negative 1. So we have y minus negative 1 is going to be plus 1 equals m times x minus negative 1 is going to be plus 1. And now we just need to know the slope of x cubed at x equals negative 1. So we are going to use y prime, the derivative of y, or I guess this is defined as f of x, so we'll say f prime x equals 3x squared. So then I want to know what f prime negative 1 is, and that's going to be 3 times negative 1 squared, which is going to be positive 3. So now I have my final equation of my tangent line is y plus 1 equals 3 times x plus 1. Okay, let's do one more. We have y equals sine x at x equals pi over 3. So again, we're going to write y minus y1 equals m times x minus x1. And we need to fill in our x1 and our y1. x1 is just pi over 3. y1 is going to be equal to sine of pi over 3, which is equal to root 3 over 2. So we have y minus square root 3 over 2 equals m times x minus pi over 3. Okay? So then now we need to know what the slope is, so we need to know what y prime is. And y prime is equal to the derivative of sine x is cosine x. Okay, so then we need to figure out what is our slope at pi over 3. Well, cosine pi over 3 is just equal to positive 1/2. So our final tangent line is y minus root 3 over 2, and that's equal to 1/2 times x minus pi over 3. That is the equation of the line tangent to our sine graph at pi over 3. Has a slope of 1/2, and it goes through the point x equals pi over 3, y equals root 3 over 2. So now I'm going to show you how to make an animation where you can represent all the possible tangent lines to a certain curve. In this case, we're going to do x squared. So rather than doing this at a specific x value, we want to be able to just pick a sliding x value and let it change. So what we're going to do is we're going to let x1 be a in Desmos. And so then if x1 is defined as a, then y1 is just going to be a squared. Now how are we going to define m? Well, we know that y prime is equal to just 2 times x by the power rule. So then I can say that our slope at x equals a is just going to be 2 times a. So what I'm going to do in Desmos is I'm going to type in y equals x squared. Or we can just, you don't have to do y equals x squared, you can just say x squared. And then in another cell, we're going to write y minus a squared equals 2a times x minus a. And then we're going to let a be a slider. So now we can let a change, and no matter what a is, it's going to produce a different equation of the tangent line, right? So let's look at an example. I just let a be 1.6. Okay, we have y equals x squared, and then we have y minus a squared equals 2a times x minus a. Okay, here's our x squared curve. And right now, this is the line tangent to this curve at x equals 1.6. But if I change this a value, then you're going to see the tangent line just wrap around this curve. But it's a way of representing all the possible tangent lines no matter what the x value is. Okay, last thing I'm going to show you is how to do this for a more complex curve. So here we have this curve defined by a of t equals 6.687 times 0.931 raised to the t power. And the question is asking for the equation of the tangent line at t equals 30. Okay, so we have been writing y minus y1 equals m times x minus x1 because x has been our independent variable. But in this case, t will be our independent variable, right? So really we should write this as a of t minus a of t1 equals m times x minus, or sorry, t minus t1. If we're going to be technical. But then if you're going to plug this into Desmos or your calculator, you're just going to be using the x value anyway, like because x is the variable that Desmos and your graphing calculator recognizes the independent variable. So I'm just showing you this because obviously this is a t variable, but in your technology, you're just going to still be using x values. Okay. And the y value is going to be determined by the function a of t. Okay, so obviously this is a more complex function where I can't just plug in the number and know what the value is. But what I can do is, in Desmos, what I'm going to do is I'm going to define the function as f of x equals 6.687 times 0.931 to the x power. Okay? Because then if I want to determine what the output is at 30, I can just write f of 30 and Desmos will calculate it for me. Okay? So if I'm going to write my equation on my tangent line, I'm going to do y minus, and then I'm just going to type in f of 30 because that's going to give me my output for me. That's going to give me my y1 equals, leave m blank for a second, times x minus 30 because our x value is equal to 30. Okay. Now what is my slope? Well, it's just going to be f prime 30. And I can just type f prime 30 out front. So now if I look at the curve defined by this function and I type in this equation here, all I have to do is type y minus f of 30 equals f prime 30 times x minus 30. And then Desmos will do all the work, or whatever graphing technology you're using, right? So y minus f of 30 equals f prime 30 times x minus 30. Here's the original curve. Okay, you can see that at 30 we have a nice tangent line going on. And that's how we can construct this tangent line without actually having to determine the y value or the slope by ourselves. We can have technology do that for us. So then in part 2, we're going to review some implicit differentiation and write equations of tangent lines of curves that are defined implicitly.